Hello and welcome to my channel. In this video I am going to continue what I've been doing as far as presenting you with difficult SAT math problems. Again, because I always say that there's just not enough practice out there for the very difficult, challenging problems, the ones that if you're shooting for, above a 650, hopefully above a 700, if you're aiming for near a perfect score, you're going to have to be able to get these. And they always come near the end of the section. So my video is making a collection of the most difficult problems that you could possibly see on there. Starting with this one. Now, this one is, the reason I wanted to point this one out, it's not that it's extremely difficult, it's just that it's easy to get tricked on this. So the question says that at a particular track event, the ratio of coaches to athletes is 1 to 26. If there are X coaches at the track meet, which of the following expressions represents the number of athletes at the track meet? So as I always say, it would be a good idea if you just pause the video and you try this one, and then when you're done, we'll see how you did. So for this one, it's just safer if you just do it out and just say the ratio of athletes, the coaches to athletes, is 1 to 26. So I would just go, there's one coach for every 26 athletes. Now, if there are X coaches, then how many athletes? This is now a proportion because we're setting this ratio equal to, and we're trying to find out another ratio. So X coaches. So because coaches was on top here, I'm going to put coaches in the numerator here. And then the number of athletes here. So right here, I don't have to do a cross multiplying because it's not that difficult, but I just want to recognize is that we got from here I had 1, and I went to X. That means I multiplied that 1 times an X. So I'd have to do the same for the denominator. If I have 26 here, I'd have to multiply the same way, do by X. Therefore, that I get 26x in the denominator here, meaning the number of athletes is represented by 26x. So moving on to number 19. This is a unit circle problem. What is the value of tan 92 pi over 3? So give this one a shot. Okay, so a couple ways to approach this. They're definitely putting more of the unit circles on the SAT recently, so you're going to want to make sure if you are not familiar with that or it's been a while, you better really do a review of that. But assuming you've kind of familiar with it, what you would do is, so the unit circle, of course, we've got pretty much a coordinate plane, and represented by that, okay, and then where you've got 0, and then this is pi over 2 up here, and then this is pi, and then this is 3 pi over 2. Well, this is a crazy number, 92 pi over 3. So what I'm going to want to do there is, so actually every trip around once is 2 pi, right? So I want to see, when you have these angles, this is way above 2 pi, right? It's more than one revolution. It's a lot of revolutions. When you have these, you want to make sure, you want to see how many revolutions you can go around, and then how much do you have left over. So 92 thirds. I type that into my calculator, and I actually get 30.66. Now, I'm not putting in the pi, I'm just doing 92 thirds. So I get 30.66 repeating pi. All right, so the 30 pi part, that means I'd be going around. Now remember, every revolution is 2 pi. So if I have 30 pi to go around, divided by 2 pi each trip, that just means I go around 15 times. But what's important is, then how much, when I've gone around for the 15th time and I'm right here, I have 0.66 pi left to keep going. We want to recognize that 0.6, repeating, is 2 thirds. That means I have 2 thirds pi that I still can keep going. Okay, so I have 2 thirds and I'm going to keep going. 2 thirds, well, that's short of 1 pi, but it's past half pi, which is right here. So you're going to be somewhere in that second quadrant. I like to, personally, I think it's much more difficult to think in terms of pi and in terms of radians. So I'm going to convert this 2 pi over 3 to degrees. So I'm going to go 2 pi over 3. The conversion you do times 180 over pi, because the pi's cancel. And I got a 3, that goes into there 60 times. So multiplying across, I get 120. So that means that I went 120 degrees farther after that 15th revolution. That means I have a reference angle here of 60. Okay, so if I have a reference angle of 60, I just like to pull that triangle, little triangle here. When you have a reference angle of 60, the ratio of the 30, 69, remember, so this is a unit circle, right? So the radius in this unit circle is 1. The hypotenuse is 1. So I'm going to put a 1 there. The side opposite 30 is half of that. And the side opposite 60 is that 1/2 times square root of 3, so we get a square root of 3 over 2. Okay, now they want tangent. So tangent would be the y value, I'll do that over here, square root of 3 over 2 divided by the x value. So, because tangent is the y over the x. So it's going to be divided by 1 over 2. Well, when you do division, you're going to keep the square root of 3 over 2. You're going to change from division to multiplication. And then you're going to flip the 1/2 to get 2 over 1. These cancel, and I get square root of 3. Now, having done all that, that's a lot of work, right? So the answer is D. Wait, stop. That's wrong. So when I watched this video over, I noticed I made a mistake. Can you see what mistake I made? Just a little careless mistake, and I wanted to show you what I did. Hopefully that will prevent you from making the same mistake. Now, we've done this hundreds of times, but this can happen. What did I do is that this reference angle here, this is in the second quadrant. Okay, so in the second quadrant, your x values, of course, this way, your x values, they are negative. So the x down here, this is my x, should be a negative 1/2. Therefore, the answer, all the other math is right, but the answer isn't square root of 3, it's a negative square root of 3, so it is actually A. So, yes, I admit I made the mistake, but it's good for you to see that. You wouldn't want to do all that work and then make that silly error, because, of course, they do put square root of 3 as an answer, so we got to be careful when we're doing the test. I want to show you a way to do this on your calculator, which would be much faster. You just need to be able to know how to get into radian mode. So let's take a look at that. Now, I want to show you how you could solve this problem just using your calculator, your TI-84. Make sure you bring that. It's very helpful. So when they're asking for what is the value of tangent of 92 pi, I can actually use my calculator to solve that. Now, you have to make sure when you do this, though, that you change the mode. So I'm going to mode, and see how it says, the third one down, it says radians. Since it's saying it's 92 over 3 pi, that means it's in radian mode. It's in the unit circle's radian measure. So I'm going to hit enter. So now I can quit out of that, and I can type in the value that they gave me, the tangent, and I'm going to do 92 divided by 3, and then I'm going to do times pi. So the order of operations, it's I can just type it in just like this. It says negative 1.73. Now you might say, well, there's no negative 1.73 in my answer choices. Yes, but you can go down and you can plug in, and you'll see that negative square root of 3 is the same thing. So that's a much faster way to do that. You might want to practice doing that, solving for radian measure on your calculator. So now for number 23, there's a right rectangular prism. It gives me the height And then it gives me the length, now it's giving me a variable, is x inches, which is 7 inches more than the width. Okay, so we've got some algebra going on here with the length, width, and the height, and then they're asking about volume. So see how you do on this one, and then check out what I got. Okay, so for this one, we can do a little sketch, but might help you. Alright, so here's that is my rectangular prism, and just change this up here. I have, the height is 9, so that's right there, that's easy. Now the length they're saying is x. I'll say that this is x. And then the width, well, now we're getting into some algebra. Let me just for now put w. Okay, so we've got information here that says that the base is x. X, which is 7 more than the width. The length, x, is 7 more than the width. I need an expression. I take that sentence, put an algebraic expression. So saying x is 7 more than the width. Okay, so notice I have two variables. I have an x and a w, and they want the volume. Of course, they want the volume. So we know that the volume is always going to be the length times the width times the height. Well, I know that the height is 9, so I'm going to do it here. My volume equals, there's the height, 9. And then right now I have the width is w, and I have that the length is x. Well, I look at the answer expressions, they're all in terms of x. So for 26, it says there's a function defined by ax squared plus bx plus c, a, b, and c are constant. So it's just a regular quadratic function model. So the graph of y equals f of x in the plane xy plane passes through the points 7, 0, and negative 3, 0. So a specific function we have now is going to pass through these zeros. Okay, so immediately there's a couple ways you could approach this. What I immediately would do, if you give me coordinates, I'm going to sketch it. Okay, sometimes it really pays if you just go, especially if it's a complicated word problem, you just go visual. Get yourself a visual. So I'm going to just draw a coordinate plane, very, very rough. And 7, 0, 1, 2, 3, 4, 5, 6, 7, something over there is, that's a point right there. It's, oops, 1, 2, 3, 4, 5, 6, 7. And I'm going to label that 7, 0 is a point right there. And then also we have it at negative 3, which is about negative 3, 0 is a point right there. Put little dashes in. So, all right. So these are actually right on the x-axis. Put them right on there. We got x. No, won't let me do that. Then I got, okay. So they're on my x-axis. So now what do I do? Well, I got to look what other information they gave me is that we know that a is an integer greater than 1. Okay, so that tells me right away that a is positive. And if you remember from these quadratics, these parabolas, if that leading coefficient is positive, that means that it opens up. Meaning that the ends, these go up. So that means as it crosses through the axis, it must be down here somewhere is where the vertex is. So, in fact, I'm looking at this and going halfway between negative 3 and 7 is positive 2. So I know that the x coordinate of the vertex is 2, but I don't know the y yet, which actually we call k. So I'm thinking, how could it help me there? So there is one way to do this where if you can remember that the vertex, the x coordinate, so in the vertex the coordinates are h comma k. That's what we use for the xy, right? So to get the h, we actually would use from this model the ax squared plus bx plus c. If we have the negative of b over 2a, that will get us that 2, that x coordinate of the vertex. So let me set that equal. So if negative b over 2a ended up getting me a 2 for the vertex x-coordinate, that means that if I cross-multiplying this, 2a times 2, that negative b equals 4a. Dividing by negative 1, now I know what b is. So we put it here, b equals negative 4a. Okay. And so now they're asking what is a plus, and actually they're asking, this is very important, pay attention to this detail, which could be the value. When it says could be the value, you got to realize that means that there could be other answers, and that means that the answer choices, they've only given one of the correct answers, and there could be others. So that was one way to solve that. There's two, or that I can think of. There's often more than one way. The one I just did was more of a visual one, and you had to remember that the vertex HK, that the H is a negative b over 2a, and so on. But here's one where if I took this model, and they're telling me that these are really the x-intercepts. So when we can write this model in the form of f of x equals a, and then this is when we do our x minus the first root, r being the root, x minus the second root. Well, the root, or the zeros we have, are a 7. So what we would do here is we would multiply this out. So I'm going to leave the a here, and I'm going to multiply the x minus 7 and the x plus 3. When I do that, I get an x squared, a minus 4x minus 21. And if I distribute in the a, I get an ax squared, take away 4 times a times x, take away 21a. So what I have now is, and then this is the f of x equals this. So what do we know? Well, look at what we've got. The model here, the model is up here, right? Where we've got the model for the quadratic is ax squared plus bx plus c. Notice in the spot where for b that we wrote negative 4 or minus 4a, because this is the x term. So really b we can find is negative 4a in this case. So I know b is the same as negative 4a. Now they want me to add a and b. So, well, a, I can just use a. And then b is negative 4a. And then what do I get there? I get negative 3a. Okay, so that's the answer. However, that's not an answer choice. Something's a little bit off here. This is where you got to read and see. They're asking which could be the value of this. Which could be. All right, I need more information here. Well, they're saying a is an integer, and it's greater than 1. Okay, so think about it. A could be, it could be a 1. It can't be 1. It's greater than 1. It could be a 2. That's an integer. A 3, a 4, and so on. Any integer. So let me see what happens if I use, let's say a is 2. If a is 2, I'll do negative 3 times 2, which is negative 6. So that could be the answer. This could be the answer. So are there other answers possible? Absolutely, because the a is any integer above 1, so a could be a 3. So let's say a is a 3, and I use this expression, negative 3 times a. Negative 3 times, if I use a 3, that's negative 9. And if I use negative 3, and if I said that a is 4, because it can be, because it's an integer, I'd get negative 12. So I keep getting different answers, but notice the negative 9 and the negative 12 are not listed here. This is why we have to be very careful when you see the words could be, could be. What that tells you is that there's more than one possible answer in existence, but they're only going to give you one of them. But it makes it a little more confusing because in your mind you might be thinking, I must not be doing something right if I'm getting multiple possibilities. So now for number 27. The function is defined by g of x equals, and then it gives you some x values in there multiplying. The value of g of 7 is 0. So give this one a shot. It is pretty challenging, but again, see how far you can get with this and then compare it to what I get. So right now I've got this function, and the value of g of 7 minus w is 0. W is a constant. So when they say something is a constant, that's very important to pay attention to that. They do this all the time in the SAT, and we may have seen the word constant, but some people just don't really, it doesn't really hit them of what that really means. Constant means it's a number that they're not telling us. It's an actual number. It's not a variable. It doesn't change in this problem. So for instance, w might be 3, but they're not telling us. It's a constant number. Okay, so what is the sum of all possible values of w? So they're saying g of 7 minus a w. Okay, so this is a function notation. So they gave us a function up here, g of x. Let's say they had said a different question with the same function. They go, oh, what is g of 3? Well, you know, what do? You plug it in the 3 everywhere you saw an x, right? So this one had an x, so I'd put a 3, and then this x minus 2 here, it would be a 3 minus 2, and then this x plus 6 squared, I would do 3 plus 6 squared, and so on, and I'd figure that out. What if they had given you g of, let's say, x minus 1? Well, you'd have to, again, replace every x in your function with x minus 1. So you would have to go x minus 1, then for the second parentheses, x minus 1, and then there's still a minus 2 there. And then you'd have to go x minus 1 plus 6, and so on. Okay, so right now they're saying put in 7 minus w. So everywhere we saw an x, so again, this was the function bringing it down here was x parentheses x minus 2 x plus 6 squared. So everywhere I see an x, I got to plug in this. We're doing g of 7 minus w. So I got to plug that in here. So I got a 7 take away w. 7 take away w, take away 2, 7 take away w plus 6, and that has to be squared. Okay, so what this is going to simplify to is 7 minus w. This is 7 minus w minus 2, so this is 5 minus w. And then this one is 7 and a 6, so this one is 13 take away w squared. Okay, so what do we do with this? Well, this was when the model, the function we put in 7 minus w. Notice here they're saying the value of that, when you use the function with a 7 minus w, the value of that is 0. Meaning this whole function here is equal to 0. Because g of 7 minus w, they said that that is 0. So I put a 0 here. Now what we need to realize is that the zero product property, right? So what that means is if any of these parentheses turns out to be 0, it wipes out all of them. The whole thing becomes 0. So for example, if w is a 7, I would put in a 7 for this w. You would get 7 minus 7, which would wipe out to 0, and the whole thing would be gone. So I can get 0 here if w is 7. Looking at this parentheses, if w is 5, that's going to do the same effect. And then this one, if w is 13, that would also wipe this out to 0. So these are all possible values for w that would make this whole function equal 0. So this is the way they ask it on grid-ins, is that there's no multiple choice, and they want you to know there's 3 answers, but that you can't grid in 3 answers. So it's saying, what is the sum? So we just have to add up the 7, the 5, and the 13, and we get 25, and 25 is the answer to that problem. So hopefully this has helped you, get you some challenging problems. Just keep working on them. You're gonna get better at them the more and more you see. And I'm gonna keep adding more and more to my channel.